Welcome, everybody, to this first part of our lecture today. And it is my pleasure to introduce Dr. Greg Wilson as our guest. So Greg actually is a self-described educator, writer, and programmer. Grew up on Vancouver Island, so he's from local here. And Greg did his main degrees, or his graduate degrees, in artificial intelligence and computer science at the University of Edinburgh, after doing a mathematics degree for his bachelor's. And he is a prolific author. So he's authored books on parallel programming, and he's edited numerous books on all aspects of software engineering and development, including books called Beautiful Code and books on software architecture, as well as looking a lot at evidence in software engineering. He spent several years working in Los Alamos National Laboratory. He helped form a startup in security. And then you also became a professor at the University of Toronto, which is, I think, when we met each other. You were there for several years, and then you left academia to spend the next few years to further develop Software Carpentry, which is a nonprofit organization to teach development concepts and software engineering concepts to thousands of research scientists around the world. He also worked at Data Camp for a while, and he's now, I think you're still working at our studio, leading the instructor program. Good. He's also led a lot of efforts in diversity and inclusion in the technical sector, and that actually, Greg, is going to be a topic later on in this course that we're going to dig into. You've looked a lot at many different aspects of software engineering, and you also wrote this paper some years ago for American Scientist on empirical software engineering. Mm-hmm. And when I was pulling out papers for the students in the course to read today, that was definitely top of my list. And that's why I invited you today to talk about that paper. So what we're going to do is I've got a few questions that I wanted to ask you. And the students, as you saw, we invited you to Slack, have also put some questions into our week 2 channel in there. And I will turn it over to them to maybe ask some of these questions as well as we get there. So, you know, one of the questions that I've never asked you is, and this is, you know, before we go to the paper, what inspired you to work in computer science and software engineering?
I don't think the webcam is good enough to show it, but I have a scar on this hand. My first degree was actually not in mathematics, it was in electrical engineering. I did a lot of math as part of that. And in one afternoon, I managed to pick up a soldering iron the wrong way around twice in the space of an hour. And the second time I had my hand under the cold water tap, the lab tech came over and said, "Have you thought about the software stream?" And he probably saved my life, because the next semester was the power transmission course with 50,000 volt lines and the big transformers. I probably wouldn't be here if I'd had to do that course. So everyone else in my family made things with their hands. I'm too clumsy to do that. So I sort of fell into typing as a way to make a living. And it turns out that most of us type programs. So didn't plan on it.
But have you ever regretted it?
Nope. If there was money in writing children's books, I could see myself doing that full time, but I think there are 5 people in Canada who make a decent living writing children's books. Oh. And, you know, I kind of like being able to pay the mortgage.
Right. So, well, going to the paper, or one of the 2 papers that I asked the students to read, can you tell us what inspired you to write that paper?
Embarrassment. Starting when I was in Edinburgh, I was a programmer working almost daily with research scientists, physics, geology, psychology, all of them paying attention to evidence in a way that my colleagues and I in computer science and software engineering weren't doing. Even today, 2 beer and a loud voice is all people need to have a strong opinion about, you know, the value of pair programming or pure functional languages or blockchain or whatever the next hot topic is. And even in disciplines that I considered soft, like psychology, right, or sociology or anthropology, more respect was paid to evidence, to what do we actually know and why do we believe it's true. If an anthropologist starts sounding off, I expect them to be able to cite some sort of research study to back up their opinion. If a software engineer is sounding off and you challenge them and say, citation, please, what you get is blank stares. And so I started looking around for what we actually did know and why we believed it was true. And I came across things like Steve McConnell's books in the late 90s and early 2000s, Code Complete and Rapid Development. And it turned out that there was a research literature. And even with a PhD in computer science, I had never encountered it. I did not know that there were people who studied how programmers actually work or how software actually behaves in the wild, which felt rather to me like being an MD and not knowing anything about genetics, not even knowing that the field existed. So I started to try to put this together, and the more I learned, the more it changed what I was teaching people about how to program. And I eventually wrote that article for American Scientist, mostly, I guess, to sum it up in my own head. Sometimes you write it down in order to figure out what you're thinking. And also because I hoped then that academic computer science and software engineering industry would actually change and start paying attention. I'm much less hopeful now than I was.
Which actually leads me to the next question. It's been a few years, right, since you wrote that paper. I think it was, what was it, 2011?
Yep.
Yeah, which is almost 10 years, which is kind of
Yep.
scary, but how fast time goes. But what do you think, has changed since then?
Nothing.
Okay.
And part of the evidence for that is, well, I can cite two things. In order for an undergraduate degree in biology to be certified in Canada, to be an accredited program, students have to spend an average of 6 hours a week in the lab over 4 years. They have to learn how to do experiments, how to collect data, how to analyze it. The average undergraduate at University of Toronto or University of Waterloo does one experiment in 4 years in their computer science classes. They go and they collect some timing data in an operating systems course, for example. Okay. So we have a chicken and egg situation. Students aren't exposed to the methods, the results, and the value of empirical research. So they don't know anything about it, so they don't expect it or look for it, so they don't support it, they don't ask for it, so nobody starts teaching it. And I do not know how to break that cycle except on a generational time scale. There is a really lovely book by Lewis Thomas called The Youngest Science. In 1920, none of the entrants to Harvard Medical School had a background in science, because being a doctor back then had nothing to do with science. It was a gentleman's profession. It was a respectable way for a man to earn a living. By 1950, you had to have organic chemistry and you had to have, I can't remember what the other one was, but you had to have done some university level science to apply. But that took a generation of hard work, and it took disasters. It took the Spanish flu, it took tuberculosis, it took the Second World War to get the medical profession to take science seriously. And even by the 1950s, when the first studies were being published in the UK showing that there was a connection between smoking and lung cancer, the head of the British Medical Association could say in all sincerity, what happens in general is of no use to a physician who must treat a specific patient. He simply didn't understand what science had to do with him. And we see exactly the same thing in our profession. We are not accountable for our mistakes. We often go well over budget with no real consequence. Why should we get better?
Interesting.
Right?
So talking about, getting better at learning, how to get better, what kinds of evidence do you trust? Right? So if you are reading a paper, and you're convinced, by this paper, maybe you're trying to decide to choose a new learning platform, or a new programming language, or, you know, even something like, you know, well, maybe this is a bit different, but whether to take the vaccine when it hopefully comes. What kind of evidence do you trust? What kind of evidence do you not trust?
Sure. Um, as a roundabout way of answering that, are people here familiar with the work of Professor Andy Stefik, University of Nevada, Las Vegas?
I know about his work, but I
Okay.
don't know if the students would.
Okay. So Andy has been studying programming languages, and in particular, the usability and learnability of programming languages. He was the one who showed, to my satisfaction, that languages like Perl are as hard for people to learn to read as a language with a randomly designed syntax.
Mm-hmm.
You can actually pick ASCII tokens at random by rolling Dungeons and Dragons dice and come up with a language that's as readable as Perl or Java or C++.
Mm-hmm.
Python and Ruby are easier to read, and he can prove that with a series of controlled experiments using methods that are borrowed from other sciences. Double-blind trials, for example. Right? That just the whole panoply of pre-registration of things that psychology and medicine have learned to do because otherwise you get the wrong answer, that are still mostly not done by computer scientists. So circling back to your original question, I take a look at disciplines where people are held accountable for their mistakes. Look at what they have learned that they have to do to minimize risk of wrong answer, and then look for people in our field who are doing that. I am depressed by the number of papers showing up at ICSI that are using the latest and greatest machine learning methods on data that is completely unreliable and biased. Right? Garbage in, garbage out, but the papers get accepted. I am depressed that there are not requirements for pre-registration of studies.
I think that's actually changing.
It is.
Yeah,
And I
slowly.
think that
Yeah.
the reproducibility crisis in psychology
Yeah.
shows us just how much room there is to improve. I will start paying attention to more of the software engineering research literature when we see it enforcing the kinds of standards that medicine was using in the 1960s and 1970s. We don't have to invent new technology here. We just have to adopt what other people have already figured out. And unfortunately, I'm 57. I don't think I'm going to live to see it.
Well, change is happening in the last few years, hopefully. Now you do have to pre-register, or no, you don't have to, but there are some efforts going in the community.
And sharing
we're
data
going to
sets.
talk about that later in the course. Yeah.
Yeah, sharing data sets is another big part of it.
Yeah. Yeah.
I don't know if you've introduced your students to Derek Jones's work.
Not yet. Not
Okay,
yet.
so he has compiled a lot of historical data sets and gone back and redone analyses from a lot of classic papers. Now, I haven't gone through it in enough detail to know how accurate his reanalyses are, but the fact that that is now possible when it wasn't at the time I wrote this paper is a hopeful sign. It's all moving very, very slowly.
So sort of following along the line of evidence and what you believe in, you know, or what convinces you. So I know you did a study with Marion Petrie on code review, practices of scientists, and you're probably also familiar with the work that she did on UML, right? So what do you think of the methods that were used in those studies?
Right. So Marion is the one who convinced me that qualitative methods can be just as rigorous and just as useful as quantitative methods. Coming from an engineering background, having worked in a physics department, my belief, my arrogance, was that if it's not a controlled experiment with data that you can do a linear regression on, it isn't science. And I was wrong. I can't imagine a controlled experiment I could do that would give the same insight as her study of why people don't use UML and why they're right not to. Right? That kind of thing comes from rigorous qualitative investigation.
Mm-hmm.
And it's painstaking work. And I think a lot of us shy away from it because it can't be automated easily. You don't wind up with a Python script that goes and scrapes GitHub, throws data at some libraries, and produces a plot. All of the work has to be done moment by moment with a human being involved in every step of it to get the insight.
Mm-hmm.
And I think that as a programmer, I'm taught to automate everything that can possibly be automated. Right? So I look at that and I think, yes, 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 well, that doesn't scale. And Marion's answer is it's not supposed to.
Mm-hmm.
We're not going to learn anything from doing 1,000 interviews that we didn't learn from the first 50, as long as we did the first 50 very, very carefully.
Mm-hmm.
And we sampled carefully, I guess.
And sample carefully and control for our own biases and see what's actually there as opposed to what we're bringing to the table. It's possible to do qualitative work very badly, but as we've learned the hard way, it's possible to do quantitative work really badly as well.
Mm-hmm. So thinking about, evidence and, the results that we get from empirical studies, you've worked a lot with industry, right, over the years. I know you've worked a lot with Mozilla, and you seem to know everybody actually everywhere. So,
I've
thinking,
never met Bruce Springsteen.
okay, I have. I have actually. I served him in a bar in Edinburgh, and I got a free ticket to his concert. So there you go. There's another bit of trivia.
I think your students are learning a lot more about you.
They are learning a lot more about me today than I probably wanted them to learn. But, that's kind of, we're trying to bring some, real life into this Zoom world here.
Sure.
So thinking about, your colleagues from industry and, what you learned, say, about, the benefits of pair programming, or, the benefits of maybe not UML, but maybe I think you suggested TLA, right, plus instead. What kind of evidence do you think would help nudge practitioners towards, using potentially more successful practices or more effective tools?
The carrots have been there for a long time. We have known about the value of code review since the 1970s. It has been indisputable for longer than many people on this call have been alive. Right? But carrots aren't enough. Carrots are provably not enough. Drug companies did not start testing their products carefully until there was legislation that made them liable for injury, illness, and death. Automobile manufacturers did not start putting in safety features until they lost class action lawsuits. We can go down the list over and over again.
Okay.
If we want change at scale, we need accountability so that the people who can make the change feel the pain of things going wrong.
Okay.
Right?
So you're saying there's a more basic problem, that it isn't about convincing people, it's about convincing people to care, or?
I think you're being more generous than I would be. It is very clear at this point, for example, that the electronic voting machines being used in the United States are easily hackable. That's beyond dispute at this point. No software developer is ever going to be fined or go to jail because of that. So what is their incentive to not keep doing things the way they're doing them? There have been massive data leakages, and programmers are never held liable. Companies might foot the bill, but the programmers themselves walk away. Facebook was in part responsible for a murderous campaign against the Rohingya, against civil unrest in Sri Lanka. The programmers who built those algorithms are not accountable for that. So what possible incentive do they have other than a fuzzy wish to do better? I would not go and see my MD if I was required to sign a form in advance saying that I absolve her of all responsibility for any harm that she does me. Neither would you. So I think we've reached the point where we've tried the carrots. Now we have to require programmers to meet the same standards as hairdressers. And I don't choose that example lightly. In every province in Canada, hairdressers who are going to administer colorants to your hair have to be certified because they're putting potentially hazardous chemicals on your skin. We live in a world where the hairdressers need to be certified and the programmers don't. And that's insane.
Actually, some of the students have posted questions
Yes.
related to that as well in Slack, and we'll come back to that. So sort of, I guess thinking, okay, so maybe I'm being optimistic. So assuming, you know, some company owners or developers or managers do care, you know, what in your experience have you found to be the kinds of evidence that shift people to change what they do or the tools that they use or how they go about their practice? What is it that makes them change, in your opinion?
So again, we don't have to invent anything new here. One of the most successful government programs in the United States ever is the US Farm Extension Program, started in the 1920s. One of the ways it works is that they take a few farmers from a community who are already interested in adopting better practices, go teach them a bit about the science behind it, help them with the tooling, show them what other people in neighboring counties, neighboring states are doing, and then send them back to their communities and let them do whatever they think is best in their situation because they know their neighbors. They understand the culture that they're in, what will work, what won't, which parts of the general theory from college are applicable to growing apricots in this particular field, right? I think that where I have seen improvement to practice, it has always been somebody who, out of personal interest, had gone off and learned something, found something out, and came back and said, I'm going to show my neighbors. This is how, for example, I saw use of version control spreading in the late 80s and early 90s.
Right.
There were a couple of people in our group who had used it before and said, we're just going to make everybody's life easier. There was no overarching revolution. There was no evangelization of things like agile. What there was, hey, we can get a better crop of apricots out this year if we spread the manure this way. Let's go do that.
So really
Because
demonstrating by example.
leading
Of
by
people
example.
that you trust. Yeah.
Yep. Yep. And that seems to be the way, for example, that medical practices spread as well.
Okay.
And if I pull up the, one of the things I've become quite interested in, I'll throw this into, do you want this in Zoom or in Slack?
Whatever you prefer, I can allow you to share.
Okay, let me throw it into Slack.
Okay.
So in the early 2000s, people working at the Veterans Administration in the United States did a study showing that the mean time to adoption of a new medical practice after its value was proven was between 40 and 60 years.
Oh,
That's after the science is settled. And they said, okay, we've got to do better.
yeah.
And so there is now a field called implementation science, which is the study of when and why and how people adopt new practices, particularly in the biomedical disciplines.
Right.
That kind of work is fascinating. And if anybody on this call is thinking about a research career, this is, I think, the most useful place you could apply yourself. We don't need more insight into how programmers actually work because we've already got lots of that nobody's acting on.
Okay.
What we need is to understand how to get people to change, how to get them to adopt new practices, new tools, new responsibilities.
Yeah.
And that is a subject that can be studied using exactly the sort of quantitative and qualitative methods that we've already got.
Yeah.
You know, Marion Petrie's work, she wouldn't have thought of it as implementation science, but her study of UML was, why didn't people adopt it? And the answer was, it didn't solve their actual problems to any noticeable degree.
Yeah. Yeah.
Right?
Yeah.
It made sense on paper. In practice, it doesn't actually help.
Yeah.
So, okay, now that we know that, there's one point sample from a much larger space. What are all of the other factors that influence adoption?
Right. Right.
There was, for many years, a very good empirical software engineering research group at Microsoft. You've collaborated with them.
Mm-hmm.
Well, they found it very frustrating to have learned so many cool things
Mm-hmm.
and then not have the authority to tell developers you have to try it.
Mm-hmm.
All they could do was go and say, please. And most people said, but I've got a deadline on Thursday.
Yeah. Yeah.
Right? And Glass's law kicks in.
Yeah.
So what should they have done instead? What might have worked? And if I can pull up another one to throw in there.
Great.
I'm
Thank
sorry, I
you
should
for
have prepped
sharing
this
these
link.
links with us through
Happy
Slack.
to. Let me see if I can find this one in a hurry. Is it okay if I link to Amazon?
Yep.
Because that's the first link that comes up.
Yep.
Okay. Sorry about
No,
that.
isn't that
Jesus doesn't need the hits.
always,
But there you
it's
go.
always the way, isn't it? You're looking for a book and it's always Amazon, not the publisher.
So there are people whose entire research career and whose entire consulting practice is devoted to organizational change. How do you get large organizations to do things differently?
Mm-hmm.
Right? And the Manson Rising book, Fearless Change, is a collection of patterns that have worked
Nice.
in other fields. How do you actually get people, and in what order do you try things?
Mm-hmm.
Because it turns out people have done this often enough that we don't have to make it all up from scratch.
Mm-hmm.
I think that the next step for anybody who wants better software engineering is to figure out how to get practitioners to pay attention to what we already know
Mm-hmm.
and to act on it. And I made this request several years ago, and it didn't get much headway. There are conferences in the biomedical field that work on a buddy system. Every researcher has to bring a practitioner and vice versa. And if you don't know one, here's the forum, go and find somebody, but you've got to register in pairs because we want to encourage those conversations.
Yeah. Yeah.
Right? ICSI is 85% researchers, 90% researchers, and the programming conferences I go to don't have any research faculty showing up. There's
Yeah.
almost a complete separation between the two cultures, and that's unhealthy.
Yeah.
I don't know how to bridge that, but there are other people who've
Yeah.
devoted their careers to figuring it out.
Yeah. I'm going to talk later today about design science, sort of, and having a problem and having stakeholders and also action research. We'll talk about that next
Yep.
week.
Yep.
Because, a lot of the students in this class are not going to go for academic career. They're going to go to industry and try to
Yep.
affect change there. And so, but the methods that we're learning, hopefully in this course, will help them, understand why one method or tool or process may be better than another. I'm actually I had a lot more questions, but I can chat to you anytime. Well, if you allow me to, but
I always learn something.
I'm going to switch to maybe letting some of the students ask some questions. And I will invite them, actually, if they want, to ask the question and to turn their video on, because then they will appear for the rest of us. And I'm looking at week 2. And I know that you had a quick look through, Greg, if there were any.
I do. I've saved a couple of those.
Okay, maybe you want to pick rather than.
Sure. So Daniel Chen said, since there's a large gap in the way a student develops software and the way industry develops software, I want a citation for that. Right? I want to know why you believe that the average professional programmer, moment by moment, is doing something different from the average student. Right? In my experience, fewer than 15% of professional paid programmers ever use an interactive debugger. Right? And that, coming down to the question about interviewing candidates, this is from Nemi Rashnika. One of the things I ask everybody to do when I'm interviewing them for a job is show me that you can use a debugger, because that separates the professionals from the amateurs. Using a symbolic debugger makes you so much more productive that if you haven't learned how to do that, you are, in my opinion, a carpenter who doesn't know how to use a lathe. There are lots of things you can do. I'm sure you can get paid to do, house framing, but you simply can't tackle skilled tasks in reasonable time. So I think that people in industry tackle larger problems on longer timescales. But if we take a look For example, okay, here's the experiment. If we were to record traces of somebody with 10 years of industry experience creating something in JavaScript and a senior undergraduate creating the same thing, could we tell them apart? You know, a Turing test, can we distinguish the students from the professionals solely by looking at how they build programs, not what programs they're building? My strong suspicion is no, that people get to be good enough and then they level off. And I know why this is. It's because the tools are never on the exam.
Yeah, I think probably, I don't know if Daniel wants to jump in. He's very welcome if he wants to, but I suspect that his question came from listening to a podcast that I had in this week's readings by Adam Barr from Microsoft. He has a book, Why Developers Write Bad Code, and he talked a lot about, you know, how, you know, students don't really learn the things that you get in industry. So I suspect that's kind of where that came from.
I was looking for the citations in Adam's book.
I haven't read his book, actually.
I'm still looking.
Okay.
Right.
Yeah.
I'm absolutely, he's got a lot of insight based on personal opinion. Does it generalize to other environments?
Yeah.
Microsoft is not typical.
Yeah.
Right. And the students that Microsoft recruits from are not typical.
Yeah.
We don't know.
Yeah, good. I think that's a good point. Yeah.
Coming down to Nimi's question, when selecting the most suitable candidate programmer, right? Yeah, checking knowledge by signing an algorithm implementation, I don't do that, right? The three things that I always check in interviews are, number one, can you handle a merge conflict with version control? Right? That is an indication to me of a certain degree of sophistication. You've worked with other people on a large enough project that you're actually bumping into each other and you've learned how to do it. Good, that's a skill that I need. Second one, can you use a symbolic debugger? Third one, show me the unit tests for whatever you've been working on recently. Right? All of these are language independent. Even with version control, I'm fluent enough these days with Mercurial that it doesn't have to be Git, although Git seems to unfortunately have won. But with all of these things, you get to show me on the code of your choice.
Yeah.
And it's surprising to me how many people with years of experience are essentially still programming in Notepad. They might be using Visual Code, you know, VS Code or some other tool, but they're using it like Notepad. They don't know that there are code extraction tools and refactoring tools built in. They're doing all of that by hand. They don't know that there are bookmarking tools built in to jump them to where is this function defined, where is this variable defined. They're searching by hand. They've never advanced beyond Notepad. And again, it's because it's never on the exam when they're undergrads.
Can I ask a follow-on question to that, actually? So in your article, I think you said that you didn't really believe that test-driven development led to higher quality code, or did I misread that?
I still don't.
Okay.
I've had several conversations with people like Davide Fucci.
Yeah.
Right? And his latest result, I think this is now 2 years old, was interesting. When they went back and reanalyzed their replication study, what they found was that it didn't seem to matter if you wrote the test and then the code or the code and then the test. What mattered was that you were alternating in lots of short increments, right?
Okay, that's interesting.
And the current hypothesis is that people who adopted test-driven development as part of the gospel of Agile in the early 2000s also at the same time shifted to lots of little increments, 5 minutes of coding, 5 minutes of testing, 10 minutes, 10 minutes, whatever. So we are now ascribing the benefit to the wrong cause, right? And misattribution is, it's a problem in medical research as well. We didn't realize there was this other thing that we had changed that was actually determining the outcome. All right, that's interesting. That's why we do science. That's a perfect example. Now, it could be that Davide is wrong, right? But this is why we do science. We want to be confused at a higher level. And do I think the fundamental problem is that there are too many jobs that any quack can get one? Well, I know a lot of people who are unemployed, so I don't think there are too many jobs. I agree that people are so desperate for programmers that they're hiring people who don't have a lot of training and skill. However, I also know that there's a lot of gatekeeping in our industry. When I think about the 3 or 4 best programmers I've worked with over a career that is now 38 years, none of them had any formal training as computer scientists. In fact, the best programmer I've ever worked with had 2 years in a rabbinical college in Brooklyn, got involved in data entry for a scriptural analysis project. One thing led to the next, and when I met him, he was writing phone switch software. Right? And that makes me wonder about the gap between what we teach in undergraduate computer science and what we do as programmers. Right? But that's a debate that I'm sure everybody's already had.
I was just thinking, could we maybe switch to some of the questions that
Please.
got a lot of votes by the class, like
Yeah.
Jordan, Sarush, and Alessandra at the top. Now they voted, they put their questions early, so maybe they got a lot of votes because they put them first. But what or did any of those kind of catch your interest to answer?
Jordan's pair programmers tend to produce code that is easier to understand. Yeah. Okay, so as Peggy mentioned, I was a professor for 3 years and 4 months, which was 3 years, 3 months, and 29 days too long. I'm not cut out for large institutions. So a lot of people have pointed out over many years that we teach students to write code but not how to read it. That code review is not a routine part of undergraduate education in computing, which is rather like having architects who are never allowed to look at other buildings or other blueprints. They're only allowed to draw their own. Right? And the pedagogical benefits of reading other people's code are undisputed. Right? Looking at other code, particularly peer code, not just code that's better, but code from people like you, has a lot of benefits. And we're running a bit short on time. I don't want to dive into it, but I think that should be a routine part of undergraduate education. And in fact, I started the Architecture of Open Source Applications project to provide the raw material for that, because there wasn't a curated set of readable pieces of code with the kind of explanation that we would actually want. And if I can pull up one more link, I'll share this with people. I recently came across another beautiful, beautiful example of what I'm looking for, and I'll throw it into the Slack. Mary Rose Cook re-implemented the core of Git in 1,000 lines of clean, modern JavaScript in order to teach yourself how it actually works. The discussion and analysis that she has put beside it is wonderful. Here's the code, but here's why. Here's why this if has to come before that. Things that software alone is not very good at capturing. We should have at least one full course, probably in the junior year, where we do nothing but read programs. But we can't just pick random programs for that. They have to be good exemplars. Diomedes Spinellis went down this road with his book on code reading, right?
Yeah.
If we're looking
Adam Barr touched on this as well. Yeah.
Absolutely.
Yeah.
And I think one of the reasons open source software succeeded was that we had to do code reviews because we didn't all work for the same company and report to the same boss. If Alessandra or Zhangzi shows up and says, here's some code I want to contribute to the project, I have to read it because I don't know you. So we had to do what people in industry had known was the right thing but hadn't adopted much earlier. And much of what I know about programming, I actually learned from particularly reading Guido van Rossum's code and other early contributors to Python. Right? Because I had to if I wanted to contribute, and I would look at it and go, okay, that's cool, which is rather like musicians listening to each other's music, which every good musician does. Right? Coming back to the questions, because I lose them when I post, it scrolls down to the bottom.
I know. The problem with Slack.
Cassandra, some sort of certification? No, I don't want certification. I want liability. certification will follow liability. If we've got a couple of minutes, do people know why credit cards are, up until recently, were much more common in North America than they were in Europe? It was because Senator William Proxmire in the 1970s got a piece of legislation passed. It said the credit card company is liable for fraud. Right? Now, the credit card companies can then decide, do they buy insurance? Do they put security measures in place? Do they have more preventive measures? What do they do? But rather than legislating a particular piece of technology, he put the responsibility where there was the power to act. Right? As a result, yeah, there is such a thing as credit card fraud, but most of us use them day by day without really thinking about it because the people who can make it safe have a vested interest in doing so. Now, years ago, Professor Larry Lessig proposed something similar for data liability. He said that the first company to collect the data should be legally and financially responsible for loss or harm. The idea was that this doesn't stop them selling the data. It means they have to be careful about who they sell it to. They have to put insurance policies in place. Market mechanisms can be efficient. You just have to design good market mechanisms. Right now, I could put a bug into a piece of software that cost people hundreds of millions of dollars around the world, and all I would have to do is say, oops. Coming down to Nimi, yep, talked about what I do in interviews. Right. Is there another one here that you'd like me to grab?
I was looking at Alessandra's question up near the top and about
Thank you.
Sweebok, and that you mentioned in your article that you were skeptical of their work.
Yeah, the first,
So what do you think we've learned now up to 2020, I guess?
I haven't bothered to look at Sweebok in the last few years. That first version paid very little attention to the empirical research that was available at the time. There was a lot of strong opinion, and I'm sure that a lot of it was right, but the equivalent manuals for medical practice, for example, are littered with references to the primary research literature. You won't be taken seriously without it. Education, I don't have the book at hand, but education is a discipline now where there are ever higher standards of evidence, both qualitative and quantitative. And if you're putting forward a policy proposal, you better be able to cite the evidence. Why does Finland have a high-performing school system? Well, here's 300 studies that tease apart various factors and dispel some of the myths. And you won't be taken seriously as a policymaker unless you've got some of that. I haven't looked at Sweebok in years. If that's the direction we've gone, that would be great. If it's not, life is short.
Let's see if there was another one. I think it's probably the last because I've already used an hour of your time and it's quite late where you are.
It's a beautiful day here, and when we're done, I'm going to go for a bike ride. So if this takes a few minutes, I'm quite happy.
All right, let's do one more from Zane.
Where is Zane?
Yeah, near the top. Zane, did you want to ask the question? Maybe not. So I'll ask it. Actually, we kind of talked about it a little bit already. Maybe I'll find one that we didn't talk about. Here's one from Shuja. The small software houses or startups do not follow a specific process.
Yeah, neither do the large ones. I have worked on 6 million line code bases. I can tell you that there are a lot more meetings. There are a lot of documents that people don't read. But Jorge Aranda's paper, The Secret Life of Bugs, is absolutely essential reading.
It's going to be on the list.
Okay.
Yeah.
So what Jorge and his colleagues found out was that they traced through the history of 21, 22, I can't remember the exact number, but a couple of dozen bugs at Microsoft. And in every single case, they found that there was some key fact, some key insight or decision that was not recorded electronically anywhere. That it all eventually came down to, Derek had a conversation with Cassandra in the hallway, the light bulb came on, and then they went and they fixed stuff. And they didn't bother to write it down because why bother? You know the answer, right? And so there is, I think, an enormous gap between the processes that we describe in books, the formal process, and the reality of how software gets made.
Mm-hmm.
Just as there is a very large gap between constitutional law and the practice of government, right? And I'm not saying that there's anything underhanded about it. It's just rules are for games.
Oh, it's good to, I mean, it's good to have a plan, right? Or it's good to
Oh,
know
absolutely.
the principles or the rules you should follow.
Absolutely. And
Yeah.
I can't remember who it was years ago who said that people who adopt clean room development and, you know, very intensive formal verification and so forth seem to produce better software faster. People who adopt agile and really do it go in the opposite direction and also produce software better and faster, from which we can draw one of two conclusions. Either the method that most of us use is the worst possible and any change would be an improvement, and there are days when I believe that, or what matters is not the particular method. What matters is that you have a method, that you have a plan, that people have a shared vision of how do we do this, so that they can collaborate effectively, so that they can hand things off to one another, so that they've got all the benefits that a surgical or nursing team has in a hospital, where they understand what they can expect from each other, and you know, if that light goes on, who's going to hold the door, right? And one sign that we're not there is that in most programming teams that I've worked with, there are almost as many editors as there are programmers, right? There's no convergence on tools. There's not even a thought that we could mandate tools. I have known programmers who've changed nationality, name, and gender without changing their text editor, right? That doesn't seem sensible to me.
Yeah, I think large companies are trying to, you know, have
So,
more uniform tools, and which
yeah.
is a story for another day, I guess. But
So interesting, interesting conversation I had last year with somebody who said, "Thank God for Docker."
mm,
I said, "What do you mean?" He said, "Well, the company has mandated that I use the following tool set. So I've got all of that installed, and I've got a Docker image that I can actually get my work done in." Right?
Yeah, removes the overhead. So Greg, we're at the end of the hour, and you know, I wanted to congratulate you again on your influential educator award that you recently won. It is a bit of a mouthful to say. I hope that I'm sure the students today realize why you won that award, because you're so passionate at, you know, helping students and talking with them, you know, about what's going on in industry and what they can do. And sort of with that in mind, I'm going to ask sort of the last question. So we're in the middle of this pandemic. The students are learning online, looking at possibly doing this for quite a long time,
Mm-hmm.
and you know, trying to get through their degrees. Some of them are going to go be developers. Some of them, you know, want to be managers. Some maybe want to go to academia. What kind of single one key piece of advice, you know, would you share with these students, given what's going on today?
Learn how to run a meeting. The
Mm,
single most useful skill I have ever learned is how to run a meeting and how to participate productively in somebody else's.
wow, that's great.
And if your students want me to come back at some point, I actually do a half hour where I can teach you the basics of how to run an effective meeting. I'd be happy to do that because it will make the world a slightly better place. We waste so much time. We get so frustrated, and it's so easy to fix.
Yeah, I'd love to take you up on that.
As it happens,
So
you know where to find me.
yes. So guys, you can turn your videos on and unmute your mics if you like, if you can remember where the setting is in Zoom to unhide your video. And I will turn this off, and we'll start to see people coming back. And this is a bit awkward over Zoom, but if you can unmute. So we see some people saying,
Just do the sparkly hands.
yeah, you know, you can clap, you can do the sparkly hands. I haven't seen that one before. I obviously need to attend your lecture on how to run a meeting.
In the future, everybody is going to learn 30 or 40 words of American Sign Language,
Ah,
right? For all those times when, right? We're all going to learn how to do this.
yeah, yeah. It's true. We're definitely seeing changes happening because of that. So, Greg, I already see people saying it would be great to have you come back and talk about running meetings. So we may call on you later on the term if that's okay. And yeah, there were some other questions that we didn't get to in the Slack channel. So Greg did join Slack. I don't know how long he'll stick around, but if you really have a burning question for him, I don't know if he would answer it, but he might.
I've thrown my email into the Zoom chat as
Oh,
well,
thank you
and
so
I'll
much.
throw it into the Slack. Just, you know, somebody slacked me a link to a GitHub repo that had a wiki page that indexed all of the spreadsheets that they were using to keep track of Slack channels. And at that point, I was just, no.
Yeah, I know. It's crazy. So having your email is a good thing. So thank you again.
Welcome.
You're welcome to stick around if you want for our fun activity, but your bike ride sounds very
My bike ride's
interesting.
calling. I've got to go get my
Okay,
wife some ice
go
cream.
enjoy your bike ride and we'll see you later.
Thank you all. Stay safe. Wash your
Yeah,
hands.
thank you.